Oi. How is everyone doing? It's good to be back. Let's make sure. Let's make sure we're good. Looks like it. Let's drop a like for ourselves. Okay, sound works. Perfecto. Mm,
Ron James, Steph Curry.
okay. Yeah, I'm just gonna check right in here. I've been trying to finish this stuff, but I've been I've been so preoccupied. I've been traveling, and today I took a little bit of rest, and I just thought to stream a little bit. We're basically at the end of what we're working on now. Just trying to get the last bit done, and that has been taking forever because I've been like moving all around the last couple of weeks. So that has not really let me focus as much as I would love to. I've been spending more energy on traveling around than I have been on working. How's everyone doing today? It's good to be back. I can't wait to be done. I just wanted to come live, engage with you, and also try to see how much work I can get done. So, pretty much, we are close to being done with this whole thing. I just need to do a few things, especially related to relationships with connections, with origin node, destination node, and the edge. And the goal is just to support generics when you're working with SurrealORM generally with nodes and edges and objects, being able to use generics and lifetime. Well, lifetime is generic itself, uh, but I'm just trying to support that to make it more robust. So if you go on masters, you would find out that you can actually use generics on your nodes and edges, basically your models. And I think that's maybe not ideal. So that's what I'm trying to support now. And I just really started opening my ID now, so I need to look at where I was and see how far I need to go. Okay, so we're working with the relate now, and we've got the edge. I believe we created, so I believe this should be just out now, because within the query builder itself, we now have like edge direction. I think it's nice to have it, and we sort of have displays, so we have arrows also. I think it was nice to separate the two, so we implement displays for arrow. I think that's kind of nice, and you can then use this arrow symbol to convert to that. I think that's that's good. And before I was using a different name for this, I can remember out arrow whatever, but now I'm simplifying it to have a consistent nomenclature with what you use in the model itself. So with that, that gives you basically the path to this arrow, right and left. Um, then this is gonna be our right and left, okay. And let's see, let's go. Okay, we have this. I should call it. Should I call this store or lookup table? Lookup. Um, Table. Let's call it that. So we've got that, and for this edge, okay. I believe edge with name director indication. How about I see how this is being used? Maybe we can improve that a little bit. Okay. How about we just, rather than doing that, we actually make that a wrapper, so it's more robust. Rather than using type alias, we can then make this a struct. And obviously with that, we'll have to implement, let's see first, here we have that. So with that we can take this off, because now we've got this. How about let's just do this. And that returns a result, which means we'll have to do that here also, and we could do this. Yep. So we'll pass in the store or lookup table, whatever, pass in the table derived attribute and the edge type. Then we go to the implementation, we're getting the create name, the current struct identifier, the field type itself, the edge type. I think this is edge. Oh, so I don't have relation anymore. Interesting. Need relation. Oh, I'm calling this edge type. Should I pass the entire date? So I'm just gonna do it. Taking string from edge direction. Okay, destination, no table name. Actually, it depends on the direction, right? If it's facing to the right, this is not necessarily the destination. It can actually be the origin. And this is what I mean. Imagine you have like user writes book. In this case, this is origin and this book is destination. But how about we do the reverse? book written by user. In this case, this is still origin and destination now, right? So we can't always call user a destination node. What's a good? Okay, maybe foreign node actually makes more sense. Foreign node. That's let's call this foreign node. Yep. Should I think I might as well just do that. Yeah, and call that foreign node, right? Yep, foreign node table name. So yep. How does he have that slash? Yep. So we get represent the schema. Yeah, I'm still contemplating if I should use a type alias there. But anyway, just call this now foreign node type alias. Let's got foreign node type alias. And this now, if you notice, we're taking the identifier, but also passing the generics. So if you have something like so you've got something like the kind of scenario I just actually created here. You have something like this, right? In this case, the foreign node, let's say for the first scenario, is gonna be you got book. So let's say you've got book. We get like the schema identifier. I'm actually thinking we shouldn't have to do this type aliasing, although it could make the code generated more readable. but then it comes with, well, generating more code. As if the code is gonna generate it, typically you shouldn't have to see the generated code. I'm actually be gravitating towards not using aliases, yeah. But anyway, let's first reason through this. So we've got this, but we need generics. And for us to get the generics, the way this would typically be represented in the struct is one of the struct is gonna be, let's say, fav books, and it's gonna be this way. This is the way you're gonna write it, right? And you're gonna have the annotation. You're gonna say something like this, basically. And the way I'm going, you shouldn't have to put that anymore. Then you've got the connection. So basically, we are um we are generating an identifier for this destination. So we're trying to alias it. So in this case, we're getting it from this foreign node table name. Basically, that would be book, yeah. And if we get that, we pascalize that. Book becomes book, and when we get that, we are then trying to alias it. But because that field could potentially have generics, let's say you've got something like, I don't know, books, you uses generics, and now you have to do, I don't know, T, which is clonable or something. You could have something like this. So how do you handle it? We also want to pass generics, and that's how and why we're gonna try to get all the generics being used on this field. And it's actually quite tricky in this case, because if you really think about it, we want the generics within this, yeah, right? We want the generics here. We don't want, or maybe we shouldn't support a scenario whereby you could have something like this or something like that. But what happens if you just try to do something like, let's say, a reference to this? Right, what happens in that kind of scenario? So in that case, we would ideally want to take the generics from within the relate. But what happens when you alias this? So let's say you've got something like this. So there are a bunch of edge cases. So what happens if you do something like this, and you, let's say you alias it and do related books? Maybe we can make a rule to prevent that or to disallow that. So what if you do something like this? Should you even be able to do that? But anyway, let's focus on the simple scenario. We need the generics from that field also. We could have used the generics from this, so you can imagine this would also have its own, because it's a super, you can think of it as a super struct to the origin and destination node. So you should have all the generics that every one of them should have. What do I mean by that? Let's say you have a write struct. So let's call it struct writes, and you've got a bunch of generics to UV, and let's say you even do something a bit interesting. You limit that to that, and bam. You have your ID, you have your in, you have your out, right? You got something like this. Well, this field should have whatever generics is used here. So if you got generics, let's say in this case your in is going to be student. So if student, whatever generic student uses has to be used by the right struct, right? Because it has to pass it down. So let's say you use some generics here, tu or tu whatever, Then out would be book, and that can also be, let's say, lifetime, you, or whatever generic is used here has to be passed to writes. We're just aliasing, so student writes book will just be student writes book. That's what we're doing basically, but in this case it's gonna be actually it's gonna be writes a and oh, pardon me. Usually you should alias it. That's the like the convention I'm using. So basically you're gonna have something like in and out. So this is gonna be in, so this itself is gonna be like a generic. Origin and destination nodes are gonna be generic, so in that case you can say book type student write book, right? So let's say got this other generic being used, and in out, okay, so we got a b t u v, right? But I would recommend that in and out actually comes first, but let's say it comes wherever, right? Now we want to say student write book. In this case, rather than write in here, you would actually have to use, say, students here, then you have book also. But what if student and book both have like generics? Let's say t and u, and this also has like, I don't know, lifetime. So how do we deal with that kind of scenario? Because the only requirement actually when you're writing this generics is that in itself has to implement the trait model, and out also has to implement the trait model, right? So let's say you've defined a struct called students, and it's got tu, something like this, and you've also got struct book, something like that. Then they have to implement model. Actually you could just do derive node, right? When you implement node on something, it automatically implements model for you. So let's see, so when you do something like this actually does this implements model trait automatically for this struct. So this also, right? And that's the only requirement here, that it implements model. But in this kind of scenario, how do we undo this kind of generic? So let's say we're saying this implements clone, this implements default, and this implements some other trait called special trait, I don't know, right? How do we undo this kind of situation whereby the generics take different kind of trait? It means that means, or let's do, actually I need to be sure about this, so why don't you do a little experiment. So let's say we go struct student, and we've got lifetime. Let's just keep it simple first, and we've got book, struct book, we got tu, title, author. So let's say we got something like this, and this should implement, I don't know, clone. This should implement special traits 1. This implements 2. So let's say special trait 1, special trait 2, and then we've got right. Right also has its own generics. Let's say even we do something more interesting. The clone or default, then in and out. So in, so these two actually, these two, let's say we've got a trait called model, and okay, let's not implement for both first, but here we then say implement model out, implement model. So we've got something like this. So what if we try to do stripe to student writes book? Write book, and we've got something like this. So this actually does take the students and book. This should now take how many generics? TU actually, you know what, this has to be separate, because I'm thinking this through as I'm working through this, just thinking about the edge cases, because if we naively just give the few generics to that, then that might actually not work as we expect it to be. So just doing like a quick proof of concept to see what we actually need to do. So in this kind of scenario, even though we're calling these two T, they are completely separate stuff. With students, T means like something that should implement clone. With book, T should implement special trait. So in this case, we would probably want to do you know, ideally when you're working with this, you should, apart from the pardon me, apart from the lifetime, I think you should just put in the concrete type here. So that might be one thing. We might tell the user, we might enforce that when you're doing your alias in here, you might as well just do it. If you want to have like, so this is what I mean. So rather than you doing all this TUV, that's one way. You could definitely do this. And yeah, we could just pass in V. Book UV struct as 3 generics, 2 were supplied. Write as 1, 2. Oh yeah, there should be one more. Yeah. So in that case, I think you probably wanna even add the concrete type. So let's say you that could be, let's put a number. Oh, respecting the type. I think that should implement, yeah. So in this case, let's say we've got something like this, but now we've got TUV. Should be 1, 2, 3, 4. So the tricky thing is we can't always tell exactly um mm, 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 how many would be for dots. So we can create some restriction that you should never alias something like this. Always inline it. That's one way we can do that. But I don't think we should. So I would be able to reliably tell um the the type, the concrete type of the destination alongside its generics. Thinking of the thinking of strategies to use. But you know one thing, if you actually think about the way we are handling this in and out, we when you implement model for edge, so if you've got like traits, let's call this edge, right? It actually should take two types, and you should have something like this. So when we want to get the original destination type, another benefit of not aliasing is we could just as well just do wherever we want to use it. Let's say we want to have a function called whatever. We could just do the type could be, so for example, if you go whatever struct, let's say the student write books, of course you have to take in all the generics used here. So let's put it here. Let's assume we have it here. You could just do something like something like this. As edge, and then you can take wherever this is, the trade bond model. Okay, it's complaining about book. So students, let's implement model for student, and model for this, and now it's gonna be complaining about book. Okay, let's implement edge for right. So do yep. We're gonna fix the lifetime. Then let's implement model for book. By this point, you have to supply the concrete type anyway. So, in and out. Generics actually make this a lot more complicated, except we have to enforce a consistent rule. Because if you try to use, let's say you have an edge generic, and let's say in one of those you have like T, and you also have the in and out. For T, if you're aliasing and you are defining the T inline, so you're saying, let's say it's type unsigned integer 32 bits, and for the other one you're still aliasing that, then it's gonna be problematic because of the way we are implementing the schema that connects the origin node to the edge, then to the destination node, because we have to share the connection implementation. Because if you're saying student writes book, student could also write blog, and writes become the common denominator. So it means if you have student write book, student write blog, you don't want to have like separate schema implementation for write book and write blog. You want to use the same, and you want to implement the destination connection method from write to book and blog within the same block. So because of that, we have to have a consistent way of handling edge, and yeah, I'm trying to think a little bit. Yeah, at that point anyway, I think. Yeah, yeah, I think because of the way we are actually accumulating. Let's see if I go down a little bit. uh, Maybe we might have to aggregate for everywhere that is used and get all the generics used uniquely, so that so for example, this is what I'm thinking. If we've got like we've got students write book, then we've got student write blog, and yeah, you're doing, they should always have similar lifetime generics. But if you use of course this is an edge case I'm dealing with. Let's say in this concrete type you've already defined this as U32 within the area, so now you've just got this, but this second one still has like some kind of like generics. So you've got something like this. Then what we actually want to do is get for everywhere you have similar edge. Hey, coding by how's it going? Hi, thanks for joining the stream. I appreciate you for joining. Where are you chatting from? How did you find the channel? It's nice to have you here. And what got you interested in Rust? Have you written some Rust before? I appreciate you for joining the stream. So in this kind of scenario, you actually want to find a common edge. So in this case, it's going to be writes and code cool. Oh, that's nice. How are you? Where are you chatting from? Then you same direction. So in this direction is going to be so let's say edge is going to be right, then direction is gonna be this. So now you then have foreign nodes would be book and block, so that when we're implementing this we can have, let's say for this we can implement book and we can also implement block while taking care of the generics of the two, so you can maybe get an idea of where we're heading, because now we need to be able to supply all the generics that this might need. So let's say in this case it's gonna be A, B. So we can't just naively take the first one. Oh, come to give encouragement. Thank you so much. I appreciate it. That means a lot to me. You know, it's not easy working on something like this for long, and you know it's a long journey. So it means a lot to me that you came to encourage. I appreciate you. Hope you're doing good. It means a lot. So we don't want to naively just take the first. So for example, we could iterate through all the field, and anywhere we find the edge with that direction, we could take that and use that with the generics alone. But that wouldn't actually be a good idea, because what happens if this, let's say when you're defining this, you already define the T, right? But yeah, you're still trying to inherit from the destination place, right? So let's say this will be used on student struct, right? And you want to inherit from one of the student generics, then you can have something like this. But in that case, if we so let's actually think a little bit clearer. Because the general idea is you want to have, so let's say we've got A, we've got B, then we've got T, yeah. Yeah. Then book. Actually, what matters more? How are we defining the right structs? Let me see. Okay, so let's see the way this is being used. Okay, H name, so that is H no. H name was this. Does that does the connection? We also need the implement generics, which I'm not using here. We also need okay, we already have it. Struct implement generics. Character constraint. So with that, let's see how we're defining that within here. So we have direction, we're using the struct original, which is coming from here. Pascalized edge name. Okay. Straight. Then we implement all the foreign node connection methods here. Okay. But do we even need the generics here? At one point, do we propagate the generics to the schema? So when you define a struct, that's a model, which basically represents, in this case, the database engine table. But a schema is a different thing entirely. So a schema is just representing the schema, the field names and types and things like that. So when we're representing that, I'm trying to recall why we're okay. Now we're handling generics. So do we have to propagate the generics to the schema definition? So that's the question. We've handled the cases for direct links and nodes and all that, but now we're trying to do for graph connection, which is a little bit more intricate, because now you're not just dealing with the the origin table, the local table, and the foreign table, but now you're dealing with the edge between the two tables, right? So that makes it a little bit more tricky, because we're trying to think through like edge cases and things to be cognizant of. I think so. Little things like that, one has to be careful. So we have so in this case, would we want to have generics here? That's the question. So it depends on how this could be used. Dun-dun. So that's one direction. The scenario I'm thinking of I can see how that could be useful. I can see, I really can. Anyway, so let's look at this again. So you have two aliases, and they could use, but basically what I'm trying to achieve is, rather than just selecting one of these and using the generics, we should actually select every type with common edge and direction. So in this case, we'll select these two, and we would use the generics from the two. So we would actually use A, B, and T, rather than just, let's say we select the first one, then we would have done this instead naively, and then we would have issues when we're trying to use the second scenario. So basically what determines this would be all the destination node type generics and lifetime. So in this case, what we are actually more interested in is, we're interested in more in the generics for book, and here we're interested in generics for block. So we just need to think through a way to deterministically get that, because at the same time we want to avoid a situation whereby we have unused generics. So if we're implementing, let's say we're implementing writes to the right hand side, what just happened there? Okay, let's go up. Okay, let's say we're implementing writes, and here okay, we actually have it here already. We're implementing something like this, and book book requires something like this, while blog requires maybe something like this. In this case, we would want to have all this. But what happens when, let's say, book just doesn't have a lifetime? Suddenly you have an unused generic, the lifetime generics, and it's going to complain. So we're also trying to avoid that kind of scenario. So there are two ways that come to mind to deal with this kind of situation. Is that we go from global maximal to local maximal. So basically, we find a common denominator, not, yeah, I would say common denominator of all these. So in this case, we find a B and T, A, B and T, which doesn't necessarily tell us the entire story of what generics for book and blog would be, or otherwise we find a way to figure out the generics for book and blog. But I'm actually trying to see if you because yeah, rather than doing this, alternative way to handle this is we could do, so this could actually solve our problem if we don't try to do aliasing. I think that would solve our problem quite easily. So rather than trying to alias that, we could actually just do wherever this is, and let's say we just take this and we do edge, and we basically just take the outs. Same goes for these. If we could do plug, yep. So if we're trying to if we do away with the type aliasing, that would actually simplify this a little bit, because now we don't even have to think about how many generics does blog or book have. We just have to take the type alias and try to use the associated types from it, which would be in or out, right? So this solves the problem, and in which case we could basically just take so there are two strategies we could use for this, but yeah, so basically we could get all the generics, unique generics, lifetime and whatever, that is used across all the fields with the same edge and direction. So in this case it's going to be ABT. We use ABT here. So in this case, even if it's just AB is present here, then ABT is current here, right? So that would help us avoid a scenario whereby we have like unused lifetime or type generics. Yep, I'm thinking through this problem as I'm trying to solve it, because I've been off things for quite a while. So with this in mind, we can maybe start implementing something. I think a few things will change a little bit. I need to clean that up, but let's see. This is okay. Tokenization. Let's take that off. First, let's look at what we're doing here. Destination node schema. What's that? um destination schema. Okay. So I think I should call that foreign node because um it's not always destination. It can also be origin depending on the direction. So I think a more appropriate naming would be, let's just call this foreign node. That would be a more appropriate naming. Foreign node. Okay, that makes sense. And now that we have this, let's call this also foreign node schema. Okay. And this should probably be called edge to I think edge to foreign nodes would probably be more intuitive. So we get the edge type. So this would be model edge model Rust type with generics. Yep. I think that's why you see we are taking the edge name as method and then edge name which direction. Yeah. We're taking that. So for each edge with direction, we get all the metadata and we aggregate that. And if you look here, we're getting the edge type, but here we're not updating the edge type. But I actually think we should get this. This should be a vector now. So if we go to edge type, we should actually get all edge types, because if we get just one of them, and we try to use the generics from that, it might actually vary from another one. So what we could do is just take all the generics and just find the uniqueness. So we could do, let's say, edge types and make that a vector, right? So here would just be the initialization, edge type. Where's it coming from? Okay, was over there before. Oh yeah, that makes sense. So it's coming from this initially, then subsequently when it's occupied, we also do node edge meta edge types, edge types, and we push. What's happening? What? Why? Destination? This should probably be foreign. Whatever now. Destination. I should call this also foreign. Node name. Yep. Foreign node schema. What's wrong with my LSP? Undo. This is a work in progress. Let's do undo variable type alias generics for same edge table direction. Yep. Let's see what we got. So find what's wrong with my LSP. That's weird. Why does the code navigation not work? Let's make it polite. Okay, I'm gonna update my a new Vim and restart it because I've not restarted in a while. Oh, did he actually kill the whole thing? Damn. Yep. I just put. Yep. Actually, I'm just gonna download it elsewhere. We're gonna put documents. Okay. So now let's zoom in a little bit. Let's check on that again. Okay, for some reason it's just not highlighting it, but we'll figure that out. I think I have an idea why that is the case. So when we do into node, okay, that doesn't give anything. What? With edge meta. actually this should return the wrapper type. So okay, it actually already does that. But okay. Why aren't we getting entry on that? About I'll do a quick little experiment. Yep, you needed to implement all those things. Okay, so now we got the great. The key is also implemented. Perfect. So now we actually want to push to that. So we want to get all the types so that we can get all the generics from all the types and not just one. So get all the rights, all the edge ties with direction alias ties, so we can find a common denominator ties between them all. That gives us the type, this gives us the foreigner schema. Edge to foreigner connection. So yeah, rather than using the type alias here, I think we should just directly use the fully qualified type path. So what do I mean? Oh, do I have the tinker? Mm, where was I doing that experiment? Uh, uh, so what I mean is, let's say we've got a struct called right. Let's take generics of int out. It takes in and out, and I'll try to sleep sooner today so I don't, because I caught up on my sleep yesterday and I feel like I don't want to regress on that again. So let's say we've got a trait called edge, which has two associated type, in and in and say out, and we have a trait in and out have to be mode implement model. So we go like model. Here we could say model, and this also model. So now we've got in, and it's gonna be actually link one in, but let's just say phantom data in, and out phantom data out, right? We've got something like this, right? Let's say we want to have a function called test that returns, well, in or out. What we could do is, let's say we've got struct, that's right, and we've got struct student, at the same time we've got struct I just took course. So we could have an alias called type, right? So it means we could do type, we could say it returns, let's say we want to say it returns course, right? This is one way we could do it. Let's just do right, and that's fine. But alternatively, we could say let's do test2, good. We could say we could go through the type alias now as edge. Okay, but now we could say give us out. So it says it's not satisfied. That's because we've not implemented edge for that. But now that it is, we have one more problem. It says it has to implement model. So I mean, we could just inline that here, or we could also use the where clause and say where blah blah blah. Yep. So suddenly we have this. Then of course, in that case, these both have to implement model, and this has to implement model also. So suddenly we could easily use this or that. Right? So if we do this, the benefit of using the second approach is if we're going to introduce generics. So let's say suddenly this could have a t other generics, right? Let's call this field this. Suddenly you could have something like this, and now you would have to do this, and now you have to do this. Okay. Oh, there's one more. So suddenly you need to, I mean, you could add it to concrete type. Let's say you type to here, or let's say I'll take this out first. But let's look at a scenario whereby you want to propagate that generics. So suddenly you've got something like this, and now you have to pass up A and T, and now this has to also take A and T. So right click in, AT in, out. Then suddenly you need to do what? Do something like A and T. Then suddenly you need to either let's pass it here at first, right? So imagine this kind of scenario where different fields could then have variable numbers of generics. It's not so easy because if we use this approach, it's gonna be tricky. It's not necessarily tricky if we want to like tell the user that. So for example, when you define a field as so let's say when you're having a field called like students, you have struct, and okay, we actually have it here up, and you want to call these like courses registered. This is a readable field. So typically you would do something like this. You use this builder method, builder type called relate. Say relate, then you put the destination, or let's say you put the foreign node. So in this case it's gonna be course. But what if course takes its own generics also? If we do it this way, then if we use this direct way, we need to figure out the generics taken by this. But the problem comes, what if the user tries to do something like this? I guess that's not a problem because you have to use relate. So one way we could do to enforce this, if we want to use this approach, is you always have to, you can't wrap relate with something else, right? So if you alias this and you do related courses, and you alias that, if you ever, sorry, if you do something like related courses, so that would be relate. No. It would be relate. Essentially, oh, sorry, that's gonna be relate course, something like this. So then you would have to take this and you do, let's say, course registered. You do this instead, but we have to just ensure that or enforce that this is the convention you have to use. When you're aliasing, you can't have like a separate stuff here, a separate type. You have to do it this way. If we can guarantee that way, then we can just basically take the problem. That even has a problem. If you alias that, then there is no way for us to get I'm sure there is a way, probably a workaround, but introduces an extra complexity for us to get the type within this, right? So I would say the most straightforward way would be to just take the edge, which has all the metadata about the origin and destination node, and just get the origin or destination node from that, right? But the only thing is, when you over this, it gives you this, which might not be, you know, the ideal thing you want, and this gives you this from, like, when you over, that's more, that you can think about that as maybe being a little bit more pleasant. So that's the trade-off we have to make. But we can also get around that by just doing recreating the type. So basically we could do something like, we already have the destination name, we Pascalize it, then we could do course, which will be the Pascalized format. Then we just do something like this. So of course, then we can then focus on this alone and do something like this. Then I mean, that would be within a separate module, so it shouldn't be a problem. But let's put an underscore here, or let's just call that course X. So we could definitely do something like this also. So this is the alternative. If you want to keep that devx of being able to over and see like course, like the type name, rather than saying this long path. So those are the things I'm thinking through. But I think I'll be gravitating towards the second or the third approach of recreating the type rather than just trying to get it from the field type. Rather, we use the edge type annotation, which would have all the generics that you might need to get the information for the foreign node. So we just need to use the fully qualified path by basically aliasing the traits edge, and we can go out or in depending on the direction, and then we can just basically focus on all the generics used by the edge rather than trying to figure out the generics used in the foreign node, and we can recreate the type alias. So I think I'll be gravitating towards that. That's probably fine. Yeah, I think that's what I'm going to be doing. I'll recreate the type rather than trying to parse out the foreign node type from the field type, and which is going to be more problematic if the user is aliasing the field type name, because we're having to use the relate builder helper struct, which is like a builder. It has a bunch of builder methods that give you some extra power. So I think I have clarity. I probably should write this down so I don't have to think this through again tomorrow. I'll just record a voice note stating what I'm trying to do. Or just rewatch this stream. But I think I've got clarity regarding how I want to approach this. I'll write a few comments because I want to try to sleep as early as possible because the time is 5 a.m. on my time in my time zone. So I want to get some rest so I can be revitalized. So basically that is coming from, rather than just naively doing this phenotype alias which comes from here, I think. So we're trying to do foreign name schema identifier. That's not ideal. I mean, we could use that for sure. Pascalized. But I think what we want to do here is something like I'm just gonna remove all this. So what would we want to do here to do? So we create something like type foreign to do, recreate destination node type from edge associated type in or out foreign rather than trying to parse it from the field concrete type, which might be problematic if a user aliases the field type, except we want to restrict users from not something like that. So you have foreign node, yep, and in that case edge edge struct alias with test. So this is all we just need to do, right? Because okay, so we could just use that instead. So we shouldn't use the field type generics in that case. In that case, where's that coming from? Oh, edge type. So we should call this edge type instead. I'll call this edge type, edge blah blah blah. Yep. So that's, yeah, we could just say, so I think that's actually what I was doing already. Type generics. Okay. So okay. So that could then be used as the return type of all these. Okay, that makes sense. Then the definition would be here. Okay, we're actually already handling that way, I believe. So I'm actually already doing that here, but the problem with that is I'm doing this twice. So for um okay, interesting. So I probably want to have something like that. You can say with generics. Then we'll get schema because we're interested in the schema. Okay, that looks good. So then we can use that instead. So we're recreating the type already. I'm happy with that. I'm just gonna push that first. Recreate work in progress. Create destination. Skip edge. Create destination of foreign node type from edge. Recreate. So guys, I did mostly like trying to think a lot of like trying to think in this stream, but I think I have more clarity. I was actually doing that already. I think I was doing it during my flight, and I have better clarity because I've been off this for a while. I've been trying to set up my gears. I've got my gimbals and whatnot. I need to set those up in the morning. So before I go out today, I'll probably just spend some time in the morning once I wake up. Maybe set up my gears first, and once I finish, I need to set up my. I got the DJI RS3 Pro combo gimbal, and I also got the DJI Osmo Park 3. So I'll be using that for my stream. Subsequently, I got the Rode Wireless Pro mic that comes with the two wireless and also the two lavalier or whatever it's called. Then of course the DJI Osmo Pocket 3 Pro combo pack comes with wireless mic also. So I've got a lot of mics now, and I've also got my Rode mic for recording music. So I could use that also. But if you've joined the stream, we've done a few stuff. It's 5:21 a.m. where I am right now, and I think even though I slept a lot throughout the day, I think it's a good idea for me to catch on my sleep so I don't start getting tired and sleepy again. I appreciate you guys for joining, and I'll try to come back in the morning, and I will try to finish this project as soon as possible. We're very close. I've just been traveling a lot. I've been traveling US, Canada, Europe. The last I would even say the last for a long time, but especially in the last couple of weeks. So I'm trying to take it easy, and I'm also trying to set up my gears and everything. But I appreciate you guys, and I'll see you guys again soon. Love you. Bye.